Hypothetical syllogism, a rule of inference. If P then Q, if Q then R, therefore, if P then R. Hypothetical syllogism, like all rules of inference, is a mini-argument composed of premises and the conclusion that they entail. The key to this rule is that the antecedent of one conditional and the consequent of another conditional are exactly the same. P can be anything and R can be anything. If P leads you to Q and Q leads you on to R, then P leads you on to R. This is the rule that allows you to skip right by the middle and go straight to the end from the beginning. We can use A, B, and C as sentence letters to see how this rule works. If A then B, if B then C, therefore, if A then C. Alright, that's a little too simple. Let's try something more complex. Let's put in A or B for P, and if C then D for Q, and A and D for R. Now we've subbed in this phrase for P. It's both the antecedent of the first conditional and of the conclusion. If C then D subs in for Q as the consequent of our first conditional and the antecedent of the second. Finally, A and D is the consequent of both the second conditional and the conclusion. This rule allows you to go straight from the beginning to the end, no matter what's there, no matter how complicated or how simple. The main operator in this rule will always be three conditionals, or three arrows. It never applies to lines with not, v, ampersand, or biconditional as the main operator. As a rule of inference, it applies only to whole lines and only in one direction. It cites two conditionals and results in a third every time. The consequent of one premise and the antecedent of the other premise must be the same. Let's see how this works with a little translation. Let's say the weather is nice. For Q, we go to the beach, and for R, we get all covered in sand. If the weather is nice, then we go to the beach. If we go to the beach, then we get all covered in sand. If the weather is nice, well, then we get all covered in sand. Going to the beach may be the reason we get covered in sand, but reasons aren't exactly what conditionals are all about, not every time. This conditional tells us that even though the connection between nice weather and getting covered to sand isn't necessarily obvious, if going to the beach is your middleman, then if the weather is nice, we'll lead you to getting covered in sand. We can also take a look at hypothetical syllogism with a truth table. As with any joint truth table, I'm highlighting all of the rows with all and only true premises. We'll check the conclusion to see if it's true every time our premises are true. Even one false conclusion would be enough to make this rule invalid and unusable. But there's no false conclusion. You always get a true conclusion if both of your premises are true. This is a valid argument, and that makes it a good rule for us. Let's see how you might be able to use it. You can use hypothetical syllogism to skip past some pretty nasty looking things, like this whole mess. Q and R if and only if S. Let's try the argument. P, therefore, Q and R if and only if S. Q and R if and only if S, then not R. Therefore, if P, then not R. Well, hypothetical syllogism lets you skip that whole messy business. That's exactly the kind of reasoning that we might do in our real life. If we know that one thing that we understand leads to something complex that we don't quite understand. That complex thing leads to a conclusion that, once again, we understand. We don't necessarily need to know all the details in the middle to know that the first thing will get us to the third. We can also put this to use in a more complex example. If x then y, and it's not the case that if y then x. If y then x, or if y then z. Therefore, if x, then not z. Well, when we see x as the antecedent of a conditional in the premise and in the conclusion, That's a good sign we might want to end up using a hypothetical syllogism. Then we see that the consequent of our conclusion is a consequent of a different conditional in our premises. That's a real good sign. We're going to want a hypothetical syllogism. If only we can find some letter, maybe y, to use to connect these. It'll take a few steps, but we'll get there. We'll simplify both parts of line 1, which will allow us to use a disjunctive syllogism, which will allow us to get to our hypothetical syllogism. If x then y, if y then z, so if x then z. Now double negation will let us match the conclusion exactly. There's not a whole lot of common errors with hypothetical syllogism, but there is one important one: single line citation. If you see something like this, if P, then if Q, then R, you might be tempted to do a hypothetical syllogism and get if P, then R, but that isn't going to work. You need both lines, like in the right-hand column here, in order to do a hypothetical syllogism, because you get quite a lot more information in that column than you do in the first. Here we know that P and Q will get you to R, but we don't know anything about if P is going to get you to Q in the first place. Here's a little example. If you're having coffee, then if you put milk in it, you're having café au lait. You can't conclude from that if you're having coffee, then you're having café au lait, because you don't know whether or not you're going to put that milk in. On the other side, though, we say something like, if you're having coffee, then you put milk in it. Maybe you do every time. Well, if you put milk in your coffee, then you're having café au lait. That's what it means, after all, coffee with milk. If you're having coffee, then you're having café au lait. When if P then Q and if Q then R are confirmed to be true separately, you're getting a lot more information than out of the double conditional in a single line. If more information is given, then more can be inferred. So don't make the mistake of using hypothetical syllogism and citing just one line. We'll see a rule for lines like if P then if Q then R a little bit later on. No need to jump the gun on that one.